Hey guys, I want to take a minute to walk you through how we read the scales on various measuring devices. We've talked about this in class, and you'll need to do this on various WebAssign assignments. So let's start with this device. It's a zoomed in version of a graduated cylinder. In this case, you can see the numbers 6 and 7 on the graduated cylinder. What you can't see is at the top, this graduated cylinder references that it is a 10 milliliter graduated cylinder. All right, so the maximum amount of fluid that graduated cylinder can hold would be 10 milliliters. And therefore, each of these markings, the 6, the 7, presumably the 8 above, would be 1 milliliter of volume. So what we need to determine is what are these individual markers if we're going to read them. And hopefully you can see that if this is 1 milliliter of volume, then there are 10 dividers in between. So each individual marking must represent 0.1 milliliters of volume. All right, so knowing what that smallest marking is really important to determine how much of that quantity we have with regard to the measurements, and specifically how many values next after the decimal place you can place, right, when we're referencing its precision. All right, so that's a good place to start, but now let's look at how we actually read a graduated cylinder. Usually you have fluid in a graduated cylinder, and fluid has cohesive forces that cause it to stick to the glass and creates this thing called a meniscus. All right, so the meniscus is this shape. Sometimes it's more pronounced than others. All right, so we call this the meniscus. And we always want to read from the bottom of the meniscus. So we want to get it to eye level. And when we look at eye level, you'll see the bottom of the meniscus is somewhere right around that area right there, right? And that looks like it's somewhere between that notch and that notch, and it's closer to the bottom one, right? So if I was going to write this measurement, well, 6 milliliters would be down here, and each notch is 0.1, so now I'm at 6.1, 6.2, and 6.3 milliliters gets me on the line at that lower notch that I referenced. It looks like the meniscus is slightly above. It's between the 3 and the 4, and this is where our estimated digit can come into play when we want to write down our measurement. So I think it's closer to the 3 than the 4, so I might estimate that it is 0.02. Right, so again, this is my guess digit. I definitely observe that it's above 6.3, not quite the 6.4. Remember, this is 6.4. This would reference 6.3. And so I'm going to guess 6.32, and that would be in milliliters. All right, so that would be what I would read on this graduated cylinder. Let's look at another device. Let's look at the triple beam balance. All right, in this case, you have 3 beams. Each one has a different scale on them, and you would slide these masses left or right until this balance actually centers on the line. And they don't show that line here, but you can see the setup. You would have had to move these things left or right to get it to balance. All right, so the way we read these, we always add up these total masses. So at baseline, we have, all right here, 100. Now, what are the units here? This is in grams. We always want to reference the units. So 100 grams. Plus, they've slid over this one here, also measured in grams. So another 90 grams. Plus this extra little bit, also measured in grams. All right, and so really, in reading this, we know we at least have 190. And the markings, this is 0 grams, 1 gram, 2 gram. So we're between 0 and 1 gram, right? So what I'm adding is somewhere above 0 and less than 1 gram. And so what would each of these smallest markings be? Again, identifying the smallest marking is critical for determining the level of precision that we have in our measurement. Well, if 0 to 1, if this is 1 gram, then the smallest marking, if there are 10 of them, must be 1/10 of a gram, 0.01 grams. All right, so when I'm counting up, I count 1, 2, 3. It's between the third and the fourth tenth of a gram. So it's definitely above 3. It's less than 4, and this is where my guess digit comes into play. It's between the 0.3 and the 0.4. I think it's closer to the 0.4, so I might say it's 0.37 grams is for that last piece, right? A half a gram, 0.5 would be right here, all right? It's definitely less than 0.5, and so we can see it's above 0.3 and less than 0.4. All right, when I add that all up, I get a value of 190.37 grams. And everything that I measure with this balance is going to have 2 decimal places. It will always have 2 decimal places on anything that's measured on this scale. All right, let's take one more measuring device now, and let's look at it. Excuse me. Look at our metric ruler. And this is really where you can see the difference in the markings on the ruler and therefore how many decimal places we can show. So the second ruler is by definition more precise because it has more markings. Now it's measuring the same thing and it's measuring it accurately. In this case, we're reading centimeters, so each whole number is 1 centimeter. And so I'm definitely at 2 centimeters, but I know I've got more than 2. I'm not quite at 3, and this is where my guess comes into play. I can estimate the next digit. I'm going to say it's 2.3 centimeters. All right, if 2.5 would be right around here, 2.3 is my guess. All right, but I can't say it's 2.32. Right? I can't really estimate 100 spaces in between the 2 and the 3, and those markings are not there to help me. So I'm left with only 1 digit as my guess digit, and in this case, it's in the 10th of a centimeter spot. So I would have to read 2.3 centimeters. Now, if you look below, you'll see that each one of the markings, there are 10 markings in between, right? So the smallest increment in this case is not centimeter, but actually 1/10 of a centimeter, 0.1 centimeters, which we call a millimeter, right? And so in this case, I definitely have 2, but I can certainly see that there is 1, 2, 3 tenths. It's definitely past the 3, and it's between the 3 and the 4 tenth mark. And so I might estimate, actually, it looks like it's about halfway between the 3 and the 4, so I might say 2.35 centimeters, right? Where that 5 is my guess digit, 3 is certain, right? 5 is the one that has the most uncertainty. But with this ruler, I can always measure 2 spaces past the decimal, whereas in the ruler above, I can only measure 1 space. So hopefully this gives you an idea of how we're looking to read different devices and how important these markings are for determining how many digits we can place after a decimal place.